Okay, now it's time for activity 3. So activity 3, you'll need a paper plate. Honestly, you could use just a sheet of paper if you wanted to. And you're going to cut it in half. And I put some arrows on the back of this one to show you the direction of plate movement. So you'll set it down on the table and do this, but I'm going to hold it up just so you can see. So this is a really, really simple demonstration. So here we've got 2 plates out of the paper plate, and this type of plate boundary, remember boundary is where 2 plates meet, okay? So at this plate boundary, you've got the kind of motion where this plate's moving, I'm just going to call it up, but in one direction, and the plate next to it is moving in the opposite direction. And so they're kind of like sliding and kind of snagging on each other. Sometimes when this happens, they get locked up. They kind of get hooked on each other, and then all of a sudden it will jolt free, and that's when an earthquake would happen. So that constant grinding and sliding next to each other can cause seismic activity or earthquakes to happen. And in the United States, there's a pretty active transform boundary. In California, you've probably heard of the San Andreas Fault, or the fact that California experiences pretty frequent earthquakes. And that's because California is right on one of these transform boundaries. Okay?